Hello, everybody. It's my honor to give a talk with you today. The topic of my talk is deep learning-based study on epileptic seizure detection. This work is joined with Xuanjie Qiu and Fang Yan. The contents of this talk include 4 parts. They are introduction, materials and methods, experiment and results, and conclusion. The work is arranged from the recent published paper on the Journal of Biomedical Signal Processing and Control. Firstly is the introduction. As we know, epilepsy is a common neurological disease with abnormal brain discharge, causing convulsions and loss of consciousness. Timely diagnosis and treatment are crucial to prevent irreversible brain damage. The traditional method of relying on the neurologist to diagnose epilepsy through visual observation has many shortcomings and is prone to misdiagnosis. It is necessary to develop a computer-assisted system to help neurologists to detect epilepsy. Deep learning technology has been successfully applied in the medical field, particularly in the detection of epileptic seizure. It is capable of automatically capturing effective features from EEG signals and achieving end-to-end seizure detection, resulting in excellent outcomes in recent years. Moreover, the DL-based epileptic seizure detection models are roughly divided into 3 categories: convolutional neural network CNN-based models, recurrent neural network RNN-based models, and hybrid models. Actually, the application of DL technology in epileptic seizure detection could reduce the workload of neurologists, promote work efficiency, and improve detection accuracy. Therefore, our work is interested in investigating the DL-based epileptic seizure detection method. So, hybrid models generally perform better because they can extract spatial and temporal epilepsy seizure information simultaneously. Present hybrid methods still have the following 2 weaknesses. 1. Most studies directly use raw EEG signals as the input, and the implied epilepsy seizure information is limited. 2. Some irrelevant and redundant information in the feature map will distract the network's attention, which negatively affects epileptic seizure detection. This figure shows the data set of the University of Bonn. This is an example of EEG signals from each of 5 subsets: A, B, C, D, and E. From top to bottom, EEG signals to A to E. The Fig 2 shows the structure of residue blocks. ResNet is emerging DL approach that has attracted much attention in recent years. The residue block is the basic component of ResNet, as shown in Fig 2. The residue block consists of 2 convolutional layers, 2 batch normalization BN layer, 2 recertifier linear units (ReLU), and an identity shortcut. The difference between ResNet and the CNN-based method is that the introduction of identity shortcut enables more gradient information to follow through, which facilitates the update of parameters. The Fig 3 shows the structure of LSTM. The basic neuron of LSTM include forget gate, input gate, cell gate, and output gate. Fig 4 shows the backward difference signals. The raw EEG signals and the corresponding first order and second order backward difference signals, where X0 is the original EEG signal. X1 is the first order backward difference signal, and X2 is the second order backward difference signal. Most previous studies directly input the raw EEG signals to the DL model. However, the epileptic seizure feature in the raw EEG signals are limited and hard to capture, resulting in poor robustness of the epileptic seizure detection model. Under this background, we aim to provide supplementary information for the DL model and improve the accuracy of epileptic seizure detection. Motivated by this, they developed a difference model for feature enhancement by calculating the first order and second order backward difference signal of the raw EEG signals, and then the generated backward difference signals together with the raw EEG signals are taken as the input of the DL model. This is the channel attention model. When using the convolutional-based method to extract features from the input signal, some irrelevant and redundant information are inevitably extracted in the feature map, which has a negative effect on epileptic seizure detection. So, our work introduced the channel attention model into the model to adaptively enhance the effect of useful information and suppress that of irrelevant and redundant information. The figure 6 shows the DARL net model, which is our model and solving above mentioned problem effectively. This is the framework of proposed DARL net model. First, the raw EEG signals are directly fed into the DARL-NET model, and the difference layer calculates the first order and second order backward difference signal to obtain additional seizure information. Then, the ResNet and LSTM extract the localized correlation feature and temporal features, respectively. Moreover, the introduced channel attention modules highlights the epileptic seizure characteristic adaptively. Finally, the fully connected layer furthers the learned high-level epileptic seizure features and gave the final epileptic seizure detection result. This is our model. During the process, we also use the 4 important index to evaluate the matrix. The first important index is accuracy, defined like this, and the precision, recall, and the F-work score. The ablation studies is necessary. In this section, carries out ablation studies to verify the effectiveness of the developed difference layer and the introduced channel attention module. 3 degraded versions of DARL net models are established, which are RL net, ARL net, DRL net models. About that, the ARL net models does not have difference layer. The DRL net model does not have the channel attention module, and the RL net models get rid of both. Experimental results are shown in Fig 7 and Fig 8. This is DARL net. This is DARL net. This is in 2-category detection task. ablation experiments. This figure 8 shows the 5-category detection task ablation experiment result. The figure 9 is the confusion matrix model of RLNet, ARLNet, DRLNet, and the DARLNet. The confusion matrix is a specific matrix used to visualize the performance of an algorithm, with each column representing the predicted value and each row representing the actual category. Fig 10 and Fig 11 shows the ablation studies result. Testing F1 scores of the 4 models on the 2-category detection tests. We notice that the red line denotes DARLNet have achieved the high F1 score, and the same result shown on the 5-category detection task also. Table 2 is the classification result of EEG signal in Haihong's study dataset. Table 3 shows the performance of AlexNet, VGG60, ResNet, 1DC-LSTM, and the proposed DARLNet model on 2 classification tasks. We notice that in the DARLNet model, the accuracy, precision, recall, the F1 score has achieved a very high score. Same result shown in the 5-class classification task also. The Fig 12 shows 2D visualization of features as the final layer in A, B, C, and D net model. Among them, dark red represents dataset A, green represents dataset B, orange represents dataset C, blue represents dataset D, and bright red represents dataset E. The less overlap between points of different colors, the better classification effect of the model. Table 5 shows the performance of proposed method and several existing methods, include A. Collected from volunteers with their eyes open. B. Collected from volunteers with their eyes closed. C. Collected from patients during the epileptic interval, and the collection location is opposite side the lesion. The collected from patients during the epileptic interval, and the collection location is inside the lesion. E. Collected from the patient during the epileptic period, and the collection location is inside the lesion. We can see this table shows the result. Okay. Finally, we conclude our research. We can find 1. Proposed a DARLNet for epileptic seizure detection, which use ResNet and LSTM in parallel to extract spatial and temporal information. 2. A difference layer and channel attention module are introduced to enhance performance. 3. The proposed method achieves high accuracy on 2 and 5 category detection tasks, and has a potential detecting similar diseases. 4. The experiments were mainly conducted on single channel dataset, and multi-channel EEG recordings will be explored in the future. Thank you very much.